Okay, awesome. I recorded that first one mirror image, so I have to do it again. Um, so what we've got is problem. No, it's not your problem. But that is. So you've got your 84 kilonewtons to the right, 51 down, 40 down, 50, 30, all with your force up and your force up right there. So first thing we started off with, that I started out with, was the net moment MA. I just said that that was the direction at the moment we were trying to find. So since this is, it doesn't matter. It really doesn't. But I like having a whole lot less negatives in my problems so that I can figure out what's going on rather than manipulating negatives in the problem. So we got your 51 times 4. I saw that you added these up together, which is fine, but it doesn't really serve your purpose if you're trying to explain to somebody what happened and what you're trying to do. So it's fine, but you know, I would always, if it's not in the same plane, like if this was a 40 and there was one right next to it that was 51, that'd be fine. But if it was, if they're not in the same plane, what I usually do is I just would put them in separate. I would just have a separate thing for them. So we got your 51 times 4 because it's 4 meters to the right of A. We have your 50. You have your 40 times 4 because it's also 4 meters away. 50 times 8, which that's good. 30 times 12 because it's 12 meters away apparently. And I said that since this guy was 84 to the right, you want to make sure that that is a negative because that is not the same direction as what we've already stated. So just think of it, if you have a force this way, it's going to torque your whole system up and around counterclockwise rather than what all these guys are doing, which is clockwise. And then we have our negative 16 FB, which is because it's 16 meters to the left and it's a force B. So when I did all that math, I came out to 788, which I hope, yep, I can see it. And then 49 and a quarter was what I found FB to be. And so, since moment doesn't change, it changes the amount of force, but it doesn't change how much force is exerted. So if it's Fy, this is definitely going to change how much force Y there is on each of the supports, but since it's only in the X direction, it's not going to change. It's only going to be 171, which is what I think we, so it was 171 net force Y, 171 kilonewtons. So it'll only be 171, but that will change it so that there's more force on the A support than on the B. And then I started going over these, but since it was mirror image, it wouldn't have mattered. So if we have a roller support, like what you guys were asking me about, roller support will have a normal force against a plane, but it'll roll, and if you put a moment on it, it'll roll as well. If it's a fixed support, that'll resist motion normally, It'll resist shear, and it'll resist moment. And then I have like a ball and socket joint. It'll resist moment, or a normal force, a shear force, but it won't resist a moment like your shoulder. You can torque it around a little bit, and it's, you know. And then I had a pin and a slot, which is these are pretty much all you're going to come up with as far as problems are concerned. You can force it to side. You can't force it up and down because it's in that slot. And you can also torque it unless it's like a circle in a slot, where then if you just torque it, it's just like your socket joint where it won't do anything. It'll just spin and spin and spin and spin. But you could still apply force that way and it would have a normal force. But that sounds like that's about it. Oh, and kind of what I was saying though was that this being here with a roller, it just says that basically if you apply a force, there will be a force on this guy. There won't be a force on that guy, because if you had them both, say you had them both as a support joint, right? Then if I put a force on it this way, you can't find you can find a moment about it, but you can't find how much force is on A versus how much force is on B, unless you we're going to use something like you could use a stress strain type thing, where if you could find how much stress this imparted over the entire over your entire structure, you would be able to find how much it's compressed or expanded based on that one force, and then you'd be able to find it on both of these. But you can't find it. It's statically indeterminate is what you'd call it if you were just using statics. But that's like mechanics and materials concept. Where you can find all of these is you should be able to find all of those in your mechanics and materials book or your statics book. They should be on one of the cover pages. And I think that's it as far as I can get. Alright. If my book actually had the cover page for it, I'd show it to you, but I don't have my statics book because I lent it to somebody. So, alright.